This is my week 14 ecosystem report video. For my ecosystem report video, I chose blue-green algae for my primary producer. Blue-green algae is also called cyanobacteria. Blue-green algae is a group of prokaryotic autotrophic microorganisms. Blue algae is a type of phytoplankton. The blue algae photosynthesizes, but some kinds of blue algae also use nitrogen to produce their energy. Phytoplankton are the base of the ocean's food web and are the food source for zooplankton. For a primary consumer, I chose the Atlantic blue tang. These certain fish can grow up to 30 centimeters long. They're autotrophs that can raise sharp venomous spines on either sides of their tails when they're in danger, which is one of their physical adaptations. My intermediate consumer is the Caribbean lobster. The Caribbean lobster is heterotrophic. They're also benthic, as they create their own heat. Caribbean lobsters have long antennas over their eyes that they wave to scare off predators. They also have smaller antennas that sense movement and detect chemicals in the water. And unlike American lobsters, they do not have large front claws to protect themselves with. I chose the blacktip reef shark for the top predator. The blacktip reef shark is a nekton that is able to navigate freely. This shark uses their pectoral fins to navigate through the water. The pectoral fins combined with its cartilaginous skeleton makes her a flexible and successful mobile predator. I chose the queen conch as a decomposer. The queen conch is herbivorous and lives on the bottom of the seafloor. They feed on macroalgae, seagrass, and citrus. Queen conches have very good camouflage and protection from other predators as their shells thicken with age. Queen conches also are able to cover themselves with sand and other sediments to hide from predators. You can see in my food web I have the blue algae, then the Atlantic blue tang, the Caribbean lobster, the blacktip reef shark, and then the queen conch. Phytoplankton form the base of the aquatic food web. They are eaten by primary consumers. Primary consumers are in turn eaten by intermediate consumers. Intermediate consumers are eaten by the top predator. The decomposer then breaks down dead organic material that is left behind. For my food web, the blue-green algae produces their own food, which is then consumed by the Atlantic blue tang. Blue tang is consumed by the Caribbean lobster, which is then consumed by the top predator. The blacktip reef shark, is then consumed by the top predator, the blacktip reef shark. The queen conch then decomposes the dead organic material that the other levels of the food chain leave behind. The food web is reliant on the organisms of each layer to contribute to each other equally. There are many abiotic factors that affect coral reef ecosystems. Temperature plays a huge role in these abiotic factors. Temperature can greatly affect a coral reef ecosystem. High temperature is stressful to corals. If the corals do not do well, other parts of the web will show that reflection and not do well or leave to find a new ecosystem to live in. Waves drive the flow rate around reefs. The exchange of water from the open ocean can help to regulate the temperature of the area so the corals don't become stressed. Coral reefs need to have clear, unpolluted water to thrive. Sunlight is how corals get their oxygen, and many of the diverse ecosystems that live within a coral reef also require steady sunlight to survive. Sediment can also greatly affect a coral reef's ecosystem. Sediment that is deposited onto reefs can smother the corals and interfere with their ability to feed, grow, and reproduce. Excess nutrients or lack of nutrients can increase bioerosion rates, increase sediment solution, and increase the growth rates of macroalgae species, which results in competition for overgrowth of corals. Many geological, chemical, and physical aspects of the ocean can impact the coral reef ecosystem. Ocean acidification greatly affects coral reef ecosystems. High levels Ocean acidification greatly affects coral reef ecosystems. High levels of carbon dioxide make it difficult for corals to form hard skeletons due to the lack of carbonate. Increasing levels of carbon dioxide causes coral branches to lose their symbiotic algae. The coral that receives their zooxanthal see a 60% reduction in net photosynthesis per cell. A reduction in photosynthesis means less available energy to coral polyps, which reduces coral health and reproductive ability. Rising seawater temperatures also negatively affects coral reefs. Warming of seawater causes corals to lose microscopic algae that produces food that corals need, which then places stress on the corals. Coral bleaching can occur without the algae needed by the corals. Severe or prolonged bleaching can kill coral colonies or leave them more vulnerable to other threats such as infectious diseases. The increasing acidity is changing the life cycle of many marine organisms, threatening their extinction and risking further destruction of coral reefs. Scientists predict that atmospheric carbon dioxide levels will reach 450 parts per million by the year 2040. This level is now believed to be the point of no return for coral reefs, and they will go into terminal decline around the world. After this, regardless of how we control carbon emissions, coral reefs may be extinct by the year 2100. The loss of coral reefs would be devastating to one of the world's largest pools of biodiversity. Coral reefs help seed the ocean and provide shelter and food to a complex web of organisms, which without the coral reefs, they would not have a home. And that leads all the way up to humans, as humans need everything that the coral reefs provide. Coral reefs act as a natural barrier to shorelines by protecting them from the effects of the water. As coral reefs die, the coastlines become more susceptible to hurricanes, storms, and cyclones. Without coral reefs, the oceans will not be able to absorb as much carbon dioxide, which will leave more CO2 in the atmosphere. The loss of coral reefs and their ecosystems would have a devastating impact on tropical countries, economies, food supplies, and the safety of their coastal communities. These impacts would immediately affect the richer industrialized countries that depend on seafood from coral reef ecosystems. So for another physical factor that affects the coral reefs, fishing and boat anchoring can also damage the coral reefs physically, which can hurt them for long periods of time or even cause them to die. And many of the organisms depend on the coral reef to thrive off of, and it provides food and shelter for them. Coral reefs are also a large spot for tourists, and a lot of countries get their money from that. So if we didn't have coral reefs, then a lot of things would be different, especially for the tropical countries that rely coral reefs of fish and like take tours around and all